Today, we're going to use Electron JS to build a basic offline persistent desktop app in JavaScript. Our starting point is the Electron+React boilerplate, which I've linked in the description below. If you don't write React or prefer a different framework, feel free to use whatever you're most comfortable with. First, let's take a quick look at the Electron framework to see what it's doing. Electron is used to create native applications from web technologies like JavaScript, HTML, and CSS. It abstracts the hard parts like building and launching your app without a browser, so you can focus on your app design. It uses Chromium, i.e. the Google Chrome engine, to instantiate windows, and you can have multiple window interfaces, each with its own render process. In our main.js file, which runs all of the central processes of the app, we import app and browser from Electron, as well as path and URL. We keep a global reference to the window object, which we're about to instantiate. And then we define the function to create the app's first window, along with some basic methods which should be fairly self-explanatory. Now we can start booting the app and declaring basic listeners. So first we'll npm install and then run npm run dev. So we finished instantiating our app and our window, but there's nothing for the user to interact with. We're going to make a few changes to the boilerplate before we dive in. First of all, we don't really need this app folder, so we'll move our main component to the components folder. We're going to rename Hello World to Home. Update imports. And just make sure we're being consistent. All right, great. Let's set up a constants file. This is going to define all of the call types that we'll send and receive between our main process and the window process. There's a little typo here. I'm going to catch it later. This is a playback. Majuk.exports. Try not to copy that word for word. So the term for communicating between main and the window is called IPC, or inter-process communication. IPC for the main process and IPC renderer for the window and the UI rendering process. It's common practice to create a renderer.js file somewhere in your client-side directory. We'll import IPC renderer and the constants we need and define the functions we'll later use in our React code to send messages to the main process. The first argument to the send method is the call type, and the second is the message. So in the future, the string items will be a key that holds an array of strings we persist in our JSON storage. Sorry, there's a little typo right there. This will take an item as a parameter. Let's console log renderer sending save data in storage to main, and then we'll send our call type with item attached. Excellent. So back in the main process, we're going to import IPC main and all four constants, since these listeners will be listening for the two sending constants and sending back the other two constants, the handlers. For now, all these listeners are going to do is to log the message sent from main, then send back the corresponding handler call, reattaching the message. But soon, we'll set up interactions with JSON storage right here. So at the bottom of the file, we'll set up our listeners. IPC main method on receives as its first argument the name of the call, and as its second argument another callback. That callback receives event as its first argument and message as its second argument. So we'll console log the message so that we can track our data flow. Finally, let's set up React. Our front-end framework will trigger the data flow and be the final stop when it receives a handler call from the main process. Well, this is a lot of code, so if you're coding along, feel free to pause the video to catch up. First, just know I'm using React hooks to manage state. Hooks may not work on this version of React because of just the package JSON from the boilerplate that I downloaded. So I'm going to update my package JSON to use next. Val's going to manage our input field, and items to track is the same array I mentioned when writing IPC functions, right? The first useEffect hook will run load save data, which is defined in renderer JS. So we want to grab the user's items from storage the first time the component mounts, the first time the app loads. So we'll use the useEffect hook and just pass in an empty array. Then on the other side of that data flow, we'll listen for the handler, and this will receive two arguments. It'll receive the handle fetch data call, as well as a callback that we'll define in a moment. Okay, so note I'm referencing and not defining the callback in the listener here, because we also need to return a remove listener function from this useEffect. If you aren't familiar with React hooks, that's because if useEffect doesn't receive an array of values to listen for changes in as its second argument, it's not going to stop running unless you return a remove listener, and for that we need the named callback. So we're calling that callback. All that callback is going to do is set the items to track array with the data that we get back from our load save data call. And we'll do a little console log here. Okay, next thing we're going to do is save an item. We'll define add item, which will call save data in storage, also defined in renderer JS. I'm going to add console logs as we go so that we can follow the data flow. Note I wrote input there. That's a typo. I'm going to catch that later. On the other side of that data flow, there will be a useEffect listening for the handle save item in storage call. So that'll be another IPC renderer on listener, and that'll receive the callback or handle new item. Also, you might have caught it on line 24. Handle receive data is missing a const declaration. That's another one that I'm going to end up catching later on while writing the code. Okay, and next we'll declare handle new item. Another thing that I might not have mentioned, that all of these callbacks receive two arguments. First one is the event, second one is the data. The data is that object that back on the other side we attached a success key and a message key. So we're going to dot off of that message key here and use it to set items. Following that is our input state manager. We want our input to be a controlled component. So we'll grab e.target.value, that's our event.target.value, and make sure that that is consistently defined with our val state variable. And I think the last function method that we have to define in this component is our handle submit. So we'll just put that to false so that we don't refresh the page. And then we'll trigger our add item, passing in val, our controlled state. Okay, so all we need here is a button that's going to trigger our handle submit. And we need an input. We'll handle change, and we'll set that value to val. And the last thing is we'll render out our items to track array so that we can see it in front of us. This is when we'll use our list component. You can just print the array items to save the time. You can create your own or copy mine here. This is the moment that I realized I had a bunch of small errors. Okay, so if I add an item in my window, it should trigger this whole data flow from renderer to main, back to renderer, and we should see it on the front end. I've also included console logs so we can track the data flow. So we see React triggered add item with apples. The renderer is sending the call save data in storage. Main receives the call save data in storage with the message apples. So we can see that right there inside of the IPC on listener function. That's going to send back handle save data with the same message, and renderer receives a new item, apples, back in our home component. Great, try it out. But we're still not persisting anything, so let's handle that next. In main.js, let's install and import storage from Electron JSON storage. If you're interested in learning more about this package, I've included the link to their repository in the description below. We will import storage at the top of main.js. We will instantiate the JavaScript variable of whatever we're storing. Now we know that when IPC main receives the call to fetch data from storage, the message is the string items. So let's use the storage method get to access items to track. Get receives as its first argument the message, and as its second argument another callback that receives error and data as its first and second arguments. So if the items key doesn't exist yet in JSON storage, it will return an empty object, and if so, we'll initialize items to track to be an empty array. So let's be sure to handle errors. And after fetching items to track from our storage, we'll send a handle fetch data call back to the window and attach items to track as the message. Now your main file has a variable it can update. And on each update, we can resave the corresponding item in storage. When IPC main receives the call to save data in storage, we'll first push the new item to the items to track array in this file, and then use the set method to save the array in JSON storage. Set is going to receive 3 arguments, the first being the key at which to store it, what you want to store there. In this case, it's going to be the items to track array that we have defined here. And then it's going to receive its callback, which receives error as a first argument. Lastly, we'll send back our handler call to the window, where our component's useEffect hook is listening for the call. Okay, this is where I know that the message that we send back from handle fetch data actually needs to be the items to track array that we just fetched. So let's add some items and see if they persist. We're going to add some apples and some bananas. We can close the app and reload. And we'll see our persistent data. Feel free to check out the description below for a few links to help you get started building your first Electron JS app, including my Boilerplate repo, an extension of the Electron+React Boilerplate, which includes a lot of documentation explaining what each piece of the puzzle is doing. Happy coding!